Hey guys, I don't know if the lighting is working. I've been trying different things. But anyway, let's go through this quickly. I want to try to make this as quick and painless as possible for you. Get out your science practice book, okay? Let's go through the answers. Make sure you guys understand the answers to this section. Actually, I'm not on the right page, so to get to the right page, or Newton's first law, page 327. That's where we are. I believe that was what the assignment was, right? 327. Let me just check it. Yep, 327, 332. So let's go through these. Go through and make sure you have the right answer. I'm going to go through, give you the right answer, make sure I explain them. Hopefully you just mark them right or wrong. If for some reason I don't explain one or don't explain it well enough, please message me and say you don't understand it, because you may need to understand these for the test. Okay? Number one, a push or pull that acts on an object is called a force. That's pretty self-explanatory. Number two, forces are needed to set objects in motion, moving motion, right? You can't get something moving without applying a force to it. Number three, the mass of an object tends to make the object resist being set in motion. It's the mass. You might have said weight, and yes, weight is true, but weight is the pull of gravity acting with the mass. So it's indirect. The more direct thing is mass. Four, the tendency of an object to resist change in its state of motion is called the object's inertia. This is what Newton's first law is all about. It's all about inertia. The tendency to resist change is inertia. It wants to sitting still, it wants to keep sitting still. If it's going, it wants to keep going the same direction it's going. Galileo imagined rolling a ball down a fixed incline, or fixed incline, I should say, and then back up ramps of varying steepness. Okay, so he down a fixed incline, okay, and then up a ramp of varying steepness. So he might have had one like this, he might have had one like this, he might have had one like that. And if there was no friction, it would always come to the same height, whether it was like this, whether it was like this, whether it was like this, it would always end up coming to the same height that it started from, okay? You could start it from here, and if it was a V like this, it would end up just going right up to that V. If it was really long and then it was elongated like that, this is the same height as here, so like this, it would end up coming to this height because it's not as steep, so it can go farther. 6, without a force to stop or slow a coasting object, the object will coast forever in a straight line. 7, friction opposes the motion of one object moving past another. Friction. It's like why, if you're rubbing your hands like this, you can feel friction preventing you from pushing your hands past another. 8, Sir Isaac Newton published and again, you can just put Newton. If you just put Newton, it's like, oh, it's not like, oh no, I'm wrong. But his full name is Sir Isaac Newton, published a complete description of the concept of inertia. That was his first law. 9, objects at rest remain at rest, and objects traveling at a steady rate in a straight line continue that way until a force acts on them. It will keep going until it's acted on by a force of any kind, including friction. 10, Newton's first law of motion tells us what I just mentioned. Next page, let's fly through this. Only 3.5 minutes so far. We're doing well. Number 11, you are moving when you are changing your position. Location, you could use that, but the official word is position. You're changing your position, that means you're moving. If you were looking at me right here and you close your eyes, and then you open them again and I'm over here, like go ahead and close your eyes. Now open them, and you see me in a different position. You know that I moved because I'm in a different position. Even if you didn't see me move, you know that I moved because I'm in a different position. 12, position is the location of an object. It's where it is. 13, the speed of a moving object is how fast its position is changing with time at any moment. So speed is just how fast you're changing, how fast you're going, how fast is your position changing, right? How quickly your position is changing. Because speed is always distance divided by time. So you move a certain location from one location to another location, that's called distance, in a certain amount of time divided by time, the rate of which the distance changes, the location changes. 14, the speed of a moving object taken together with its direction gives us the velocity. Remember, speed is how fast it's going, velocity is how fast it's going in a certain direction. 15, two objects can have the same speed but different velocities if they are traveling in different directions. Okay, you can have the same speed if you're going north and south, you can actually have the same speed, so 50 miles per hour north, 50 miles per hour south, but you have a different velocity if you're going 50 miles per hour north and 50 miles per hour south. That's different velocities but the same speed, because with speed you don't give a direction, you say 50 miles per hour. If I say 50 miles per hour north, that's a velocity. What that means as well, really cool concept, what that means is if you're going around in a circle like on a merry-go-round, even though your speed isn't changing, it's a constant speed, you are actually accelerating. Think about that. You're actually accelerating on a merry-go-round, even if it's going at constant speed. It's not speeding up or slowing down. You're accelerating because your direction is changing. Okay, you're going like this, and because acceleration, which we're going to talk about in a second, acceleration is a change in the velocity. The velocity is how fast you're going in a direction. Well, is the speed changing? How fast you're going? Nope. But is the direction changing? Yes. So therefore, there is a change. Therefore, it is accelerating. 16, as long as an object travels in a straight line at a steady speed, its velocity is constant. So that would be zero acceleration. 17, a change in velocity is called acceleration. 18, deceleration occurs when a force causes the speed of an object to decrease. Remember, deceleration isn't the opposite of acceleration. It's a special type of acceleration, meaning to slow down. If you speed up, you're accelerating. If you slow down, you're accelerating. All of them mean accelerating. If you change direction, you're accelerating. Accelerating just means the velocity changes somehow, okay? We usually think of acceleration as meaning speed up, but it doesn't just mean speed up, it just means the velocity changes somehow. Deceleration is a special word that means slow down, and sometimes people may confuse that and say deceleration is slowing down, acceleration is speeding up, but it's not necessarily the case. I'm going to ask you that on the test. You got to get that right. 19. What keeps things moving in a circle? Gravity is the force that keeps Earth moving in a circular path around the sun. If gravity didn't exist, the Earth would go flying out into space. And if inertia didn't exist, the Earth would get pulled into the sun. All right, 3:29. We're at 7 minutes. All right, 3.5 minutes. We average about 3.5 minutes per page, but we're going to speed up. Number 1, what might be acting on the ball? So you have this little diagram of the ball going up and down and up. What might be acting on the ball to make it stop at points B and C? The correct answer here is inertia. Inertia meaning it's tendency of an object to resist changing. But I like a different answer better, being gravity, because gravity is pulling at it. Inertia would keep the ball moving, but gravity is pulling that ball back down. So I think it's kind of worded poorly, but it's one of those things. If you said, I don't even know what other answer you could say. I would have accepted gravity though. 2, could you assemble a ramp that allowed the ball that started at point A to rise to a height that would be higher than the line drawn between A and B? No, you could not. You could never, what that's asking is, could you start the ball at A and then have it go down somehow and go and end up higher? You can't. You would never be able to have the ball go down and come up higher. It could be lower because of friction and loss of energy and stuff, but you could never actually have it higher, because as it goes up, its speed is getting slower and slower and slower, and even in a completely frictionless environment, eventually it would just end up at the exact same height. It works the same way if you throw something up too. If I throw something up at 20 miles per hour and it goes up and gets to 0 at the top and then starts speeding back up on the way down, whatever height I threw it up at, it's the same speed coming down. It's 20 miles per hour on the way down. 2, could you assemble a ramp that allowed a ball, no, we already did that one. 3, if the ball traveled from point A up ramp B and stopped at point B, would remain there indefinitely? Hopefully you guys all got this right. It's basically saying if you started a ball at A, dropped it, and it rolled down and went to B, would it stay at B forever? No, because it would just be hanging there in the air. It doesn't make any sense. It rolled back down and probably like this, and then like this, and then like this, and then eventually settle at the bottom. All right, that one was less than 2 minutes. Let's go even faster for this page. Number 1, if a plane continues to travel the same direction and reaches I-7, okay, remember you trace over here to I and then go up to 7, on the grid 1 second after passing through H8, okay, has its speed changed? Yes. I mean, it just puts yes on there, but the reason why you know is because it's not consistent. It's not a consistent one like that, because it's 1 second passes between each plane, and if all of a sudden it goes from I7 to H8 1 second. Now it's actually slowed down. Number 2, how would the speed of the plane have changed if the plane reaches I7 2 seconds after passing through H8? Okay, it would have slowed down because basically you look at the distance between the two positions, and if it's like this much for 1 second each time, and all of a sudden after 2 seconds it's this much, that means that it covered a smaller distance in even more time, so it slowed way down. How would the speed of the plane have changed if the plane reaches L1 on the grid in less than a second after passing through H8? Well, that would mean that its speed was that the distance between the different planes was the same, and all of a sudden after less time, it's huge. So that would mean that it's sped up. All right, that was about 1 minute. I did good on that one. 331 might take a little longer on this page, but hopefully not. Number 1, a force called friction opposes the motion of one object past another. 2, position is the location of an object. 3, a push or pull that acts on an object is called a force. 4, a change in velocity is called acceleration. 5, the speed of an object is how fast its position is changing with time at any moment. Number 6, the tendency of an object to resist a change in state of motion is called an object's inertia. Inertia is a tendency. It's not a force or anything. It's a tendency. What it has a tendency to do, right? If you had a tendency to, I don't know, let's see. I have a tendency when I have a plate of food, right? I have a tendency, let's say I have 3 or 4 different things on the plate. I have a tendency to eat the thing that I like the least first. Okay, let's say I had squash on there. I don't hate squash, but I don't love it either. I'm probably going to eat the squash first just to get it out of the way. And if there's like a nice mac and cheese there, probably saving that for last, or a steak or something. I'm probably saving that for last because I love it. I want to just get the stuff I don't like out of the way, eat it. The vegetables that Mrs. Hanley makes me eat, get them out of the way, and then I just savor the rest of it. That's my tendency. I have a tendency to do that. It's almost like a rule that I do, but it's not really a rule I have to follow, but it's just something that ends up happening all the time. That's what inertia is. 7, deceleration occurs when a force causes the speed of an object to decrease. 8, the speed of an object taken together with its direction gives the velocity of an object. 9, what are 2 ways that an object's velocity can change? Well, if an object's velocity can change in that how fast it's going can change, its speed can change. Also, its direction can change because there are 2 components to velocity. It's how big it is, which is its speed, and its direction. Number 10, describe 2 forces that affect an object's velocity. Well, 2 things that can affect an object's velocity. You could have multiple different things, but one of which is friction. If hold on, Charlotte, give me 1 second. If an object's going at a certain speed, if there's friction, it could slow it down, right? Also gravity. If an object is thrown up in the air, gravity is going to start pulling it back down. All right, 1 more page and we are all done. Okay, let me take a quick drink. As long as an object travels in a straight line at a steady speed, its velocity is constant. Newton's first law tells us that an object's velocity will remain constant unless a force is applied to it. A force may change an object's speed or its direction of travel, or both. A change in an object's velocity is called acceleration. Any change is called acceleration. Newton realized that applying a force to an object would overcome its inertia and change its velocity, causing it to accelerate. A special case of acceleration, notice it didn't say the opposite, a special case of acceleration called deceleration occurs when a force causes the speed of an object to decrease. Do you need help, Charlotte? You okay? Okay. Almost done. A force called gravity pulls on Earth and keeps Earth moving in a circular path about the sun. Without the force of gravity, Earth would fly off in a straight line to deep space. All right, that's it. You guys got it. Good job. Hopefully you got all or at least most of those right. Bye.